Okay, here's the solutions for Worksheet 5. So, how many bits are transmitted per frame with 9600 8-in-1 USART communications? Well, 9600 refers to the speed, bits per second. 8 is the bits per frame. N is no parity, and 1 means one stop bit. And every frame has a start bit, so you have one start bit plus 8 data bits plus one stop bit, so that's 10 bits per frame. What is the width in seconds of a frame of a bit? What is the width in seconds of a bit transmitted at 115-200 bits per second? So the time, the seconds per bit, is equal to 1 over the bits per second, which is equal to 1 over 115/200, which is a simple thing to just plug into your calculator if you have a calculator. .68 microseconds. There's some other change out here. What is the width in seconds of an 8-bit frame with one stop bit, no parity? So we'll just use the bit rate from above, but I should have used that in the problem. But from this bit rate from above, we already know the time for a single bit. It's 8.68 microseconds. So the entire frame would be 10 times that, because there's 10 bits. So it's 10 times 8.6, which is 86.8 microseconds. If you need to transmit in a single direction at a time in both directions, what duplex scheme or schemes could you use? We could either use half duplex or full duplex. Half or full. If FOS is 8 megahertz and the formula for calculating the value for the SPBRG for 2400 bits per second is FOS divided by the desired baud rate divided by 64 minus 1, then what is the value for the SPBRG? So that would be FOS divided by the desired baud rate, so it's 8 megahertz divided by 2400 bits per second. And then this whole thing is divided by 64, and this whole thing subtract 1. Well, 8 megahertz is 8 million and 2400, so this whole thing works out to 51.0833. But what is the value for the SPBGR? So SPBGR is an 8-bit register, so all this has to be truncated, so the answer is just 51. If FOS is 8 megahertz, SPBRG is 25, and the formula for calculating the actual bit rate of the USART is FOS divided by 64 times SPBGR plus 1, then what is the actual bit rate for this SPBRG value? So let's just plug the values in. So it's 8 megahertz divided by 64 times 25 plus 1, where FOS is 8 megahertz, SPBGR is 25. So let's calculate this. This comes out to 4807.692 bits per second. If our desired bit rate is 115/200 and our actual bit rate is 116/312, using the following formula, what is the percentage error from our desired bit rate? The percentage error is the calculated baud rate minus the desired baud rate. So our desired was 115,200, so this would be error percent is equal to calculated, which is 116,3112 minus 115,200 divided by our desired baud rate of 115,200 times 100%. This comes out to 0.965%. So less than 1% error. And so it says, will the error rate from the previous question be acceptable for most systems? I'm going to say yes, because that's 1% error per bit. So it's about 1%. This is about 1% error per bit. And so if we transmit 10 bits, 10 times 1%, so because you get 1% error per bit, is going to be equal to 10%